Today our topic is surface area of solids. So our learning target is how can I find the surface area of prisms, pyramids, cylinders, and cones. All right, so first off, some key terms. Prism, we talked about this last lesson. Polyhedron with two congruent faces called bases. So bases are usually your top and bottom. So here in this drawing they are the red shading, and then this bottom piece that is still blue. The lateral faces are the parallelograms that form the other faces of the prism, so they kind of wrap around and form the outer edge. Lateral edges, segments connecting the lateral faces. Surface area is the sum of the area of all of its faces, so however many faces it has, adding up them all together. The lateral area is then the sum of the areas of the lateral faces. A net is the two-dimensional representation of a solid. So if you open up the solid, it forms what we call a net. So if you flip over to the back of your resource sheet, there are a bunch of examples of nets on there. So this is what a cube looks like when it's opened up. This is what a cuboid looks like when it's opened up. It's another word for rectangular prism. Here was what a triangular prism would look like, the triangular bases. And then these would be your lateral faces. Square-based pyramid, tetrahedron. A cone looks like this when it's opened up, so it makes this funky curved triangular shape. And then if we keep going, we've got a hexagonal prism, a hexagonal pyramid, and then a cylinder. Cylinder looks like this when opened up. It's got a rectangle for its lateral face, and then two circles for its bases. All right, so you're going to learn some formulas to find surface area, and the formulas are only going to work for right figures. So here we have a right prism, here we have a right cylinder, and here we have a right cone. So the height is straight up and down. So here our altitude or our height is straight up and down. The bases are nicely aligned. And here the cone is centered over the middle. The top of your cone, that vertex, is centered over the middle of the circle. If you look over here on the right, we have a oblique. That would be the way. Oblique prisms, cylinders, and cones. And if you look, they kind of slant, so the bases aren't aligned to each other. Our triangle here is off to the left of the triangle on the bottom. Here, our cylinder, same concept. The circles do not align. We have a slant. And here on the cone, our vertex does not align with the center of our circle. So there's that slant there. So our formulas will only work for the right figures. If you do get an oblique figure, which we will not be working with right now, you would have to open it up, make a net like we saw here, and then find the areas and add them up. But for right figures, we have some formulas that help to make the process easier, and then you don't have to draw a net. So the surface area of a right prism, so you see that? The surface area S of a right prism is S equals 2B plus pH, or you can say AP plus pH, where A is the apothem of the base, B is the area of a base, P is the perimeter of a base, and H is the height. All right, so remember that apothem is the height of one of those triangles. So if you look down here at that example on the base, they make the triangle, and then the apothem would be the height, okay? So we are looking for a couple different things. We need to find the apothem. We need to find the perimeter, which remember the perimeter is the number of sides times the side length. And then we need to find the height of the figure. Now, some of these will be given for us, which is really nice. So let's look at what we're given. We are given the side length, 7.05, which is helpful for the perimeter. And we also know it's a pentagonal prism, which means the number of sides is 5. So we are going to be able to find the perimeter of the figure by doing 5 times 7.05, which is going to give us 35.25. The height of our prism is given to us 9 feet, so that one's easy. The apothem is something we are going to have to solve for, but we have all the pieces we need. We know that the hypotenuse here, the radius of our pentagon, is 6 feet. And then we know the side length, so all we have to do is cut that in half. So 7.05 cut in half is 3.525. And then we can use Pythagorean theorem because we have a right triangle where we know the hypotenuse, we know one side length, and we're just looking for that other leg. So if we use Pythagorean theorem, which I believe you are all comfortable with, so I'm not going to go into detail on how to do that, we get 4.86. So now we have all the pieces that we need. And we just plug them into our formula right here. So surface area equals AP plus PH. Plug in the numbers. Surface area equals A, so 4.86, times P, 35.25, plus P times H, so 35.25 times our H. Type it all into the calculator to solve, and we get that the surface area is 488.57, and our units are feet squared. It is squared because it is an area. Next piece is cylinders. So if you look at a cylinder, the base is a circle, so to find the area of the base, you would do pi r squared. The base of the cone, it unwraps into a nice rectangle, so the rectangle would be your lateral area. Okay, so the surface area of a right cylinder, so nicely aligned top and bottom, the surface area is 2 times your base plus the circumference times the height, or otherwise known as 2 pi r squared plus 2 pi r h. This is something you should have learned in 7th grade. 2 pi r squared plus 2 pi r h. I taught that to my 7th graders when I was student teaching, so we should make sure we remember that. Surface area equals 2 pi r squared plus 2 pi r h. Got a nice little ring to it. So in example 2, we're looking for the height. So we want to figure out what this h is of the right cylinder shown, which has a surface area of 157.08 square meters. So we can plug in 157.08 for our surface area equals 2 pi r. Now if we look at our diagram, we are given our radius, which is 2.5, plus 2 pi r is 2.5 times h. Now we just need to solve for h. So this is just like solving an equation. We can figure out what this is by using our calculator. 2 times pi times 2.5 squared is 39.27. Plus 2 pi times 2.5 times h, which gives us 15.71 h. So just multiplying these guys together equals 157.08. Now we just need to get h all by itself, solving for that variable. So we want to minus 39.27. We're left with 15.71 h on the right equals 117.81. Last step is divide both sides by that 15.71, so we get h by itself. H equals 7.5, and our dimensions are meters, so it would be 7.5 meters. Next example on the back, a couple more key terms. A pyramid, if you remember, is a polyhedron with one polygon base and then triangular lateral faces. So they all come together at a point. The base is a polygon, so here a base is a square. And then the sides that form the lateral faces are triangles. The vertex is that point where your triangular lateral faces meet. Now a regular pyramid is a pyramid with regular polygon bases and isosceles triangles for the lateral faces. Slant height is the height of a lateral face of the regular pyramid. So if you look at our diagram, slant height is really this height that's slanted along the side. So it's the height of these triangles. And in a regular pyramid, the slant height will always be the same. for all of the triangle faces. So that is why our surface area of a regular pyramid formula only works for a regular pyramid. So it has to be a regular pyramid. So you have to see, if you look in example 3, it says a regular hexagonal pyramid. So as long as you see that word regular, you can use the formula. So our formula is B plus 1/2 PL. So B is the area of the base. P is the perimeter of the base. And L is that slant height. Okay, so the area of the base, we're going back to 11.6 where we talked about area of regular polygons. And if you remember, that formula is equal to 1/2 times A, the apothem, times the perimeter, which is number of sides, times the side length. So we are going to have to go back and use that formula. So before we try and calculate the surface area, let's find all the pieces. We want to find the area of the base, which is 1/2 times A times N times S. We need to find the perimeter of the base, which is going to just be the N times S piece right there. And then we need to find the slant height, L. We use a cursive L. So let's look at our diagram, see what our diagram gives us. It does give us our slant height, that height of one of the isosceles triangles. So we can plug in 14 for L. We know the side length is 10, so for our perimeter, 10 is the side length. And we also know the number of sides because we are told it's a hexagonal pyramid, so the number of sides is 6. And then we also are given the apothem, which is really nice. We don't have to do any solving for that, so we can figure out the area of the base as well. Now, if we solve for all of these, the area of the base is 259.81. The perimeter is 60, and we already know that the slant height is 14. So now we just need to plug those into our surface area formula, which is area of the base plus 1/2 the perimeter times the slant height. So surface area equals our area of our base, which is 259.81 plus 1/2 times our perimeter, which is 60, times our slant height, which is 14. Use your calculator to evaluate what that is, and we get 679.81. Our dimensions are feet, so it is going to be feet squared. All right, one last example. I do apologize for the length of this video. Just bear with me for one more example. Surface area of a right cone. So surface area of a right cone is given here. B is the area of the base. C is the circumference of the base, and R is the radius of the base, and L is the slant height. So if you just use this formula right here, pi r squared plus pi r L, pretty simple. S equals pi r squared plus pi r L. Need to know two things, radius and slant height. Radius is given for us. It's this 15 right here. We can plug that in. And now we just need to know what that slant height is. And for that, we're going to need to go back to the Pythagorean theorem, because our slant height is going to be this side right here. And if you look, makes a right triangle. So we know we have 20 here. We're looking for our slant height, which is L. 15. Use your Pythagorean theorem, and we get L is equal to 25. Now we have all the pieces to our formula. We just need to plug those into a calculator, and that gives us 1884.96 yards squared. Now that is just a surface area piece, which I did first. The lateral area of the right cone is this last piece here. The lateral area of a cone is just that pi r L piece. So if we can figure out what pi r L is, that'll give us our lateral area. So lateral area is equal to pi r L. We already have all the pieces. Our radius is 15. Our slant height L is 25. plug those into a calculator, and we get our lateral area is 1,178.1 yards squared. All right, that's all the notes I have for you today. Thank you for sticking with me and watching the whole video. Again, I do apologize for the length. I'll make it up to you on the next video.